Hi students, today we are going to revise the Cbse sample paper released in the Cbse website. Especially physics we are going to see for the term 2, okay. Section A, it is a 2-mark question, okay. So the marks allotted for this question is 2 marks. What is the question? Let us read now. A simple motor is made in a school laboratory. A coil of wire is mounted on an axle, okay, on an axle between the poles of a horseshoe magnet. So here you have to imagine there is a horseshoe magnet. So horseshoe magnet is kept such that the poles are only visible in the picture. The remaining U-shaped portion is not shown, okay. So it is like this. A, B, C, D, okay, is a coil. Now, subdivision A of this question number 6 is, for this position, okay, for this position, state the direction of the force on the arm AB, okay, on the arm AB. We have to first find the direction of the force. So, let us imagine this is a rectangular coil, okay, this is a rectangular coil. This is mounted, okay, between the poles of the horseshoe magnet. You see here, students. So you have to imagine as if this coil is perpendicular to the plane of the board. So this side is the south pole and this opposite side is the north pole, from left to right. Okay. So it's a 3-dimensional picture given in the illustration. So when this coil is placed like this, you must know that this portion, okay, so this portion AB is perpendicular to the magnetic field and CD also is perpendicular to the magnetic field. So I am going to draw the direction of the magnetic lines of force. So these are the directions of magnetic lines of force, that is magnetic flux. Or you can say that there is a direction of the magnetic field itself, okay, this is the direction of the magnetic field, okay. Now you can see that the springy contacts, namely the brushes, okay, are connected to the positive and negative of a battery. So below this they have given in the above example, coil ABCD is horizontal and the battery is connected as shown, so that the coil is horizontal, okay. So battery is connected such that the end A is connected to the positive and the end D is connected to the negative. Okay, now you tell me in which direction does the conventional current will flow. You are all very thorough, is it not, in the regular class? It starts from the positive terminal of the battery. Okay. So the conventional current will start from the positive terminal and it will flow in the arm AB from A to B. Then here it flows from B to C and then C to D, understand? And then D to the other ring and then it will reach the negative terminal. So that one full cycle, okay, is over. Now you have to watch the direction of current flow in the coil in various branches. So in the branch AB and CD, when current flows, the direction of the current, you see here, this is the direction of the current. Is it perpendicular to the magnetic field lines or not? You see here, everywhere this current direction is perpendicular to the direction of the magnetic field. But when the same current will flow in the arm B to C, it is parallel to the direction, understand? It is parallel to the direction of the magnetic field. So first you have to understand this fact. So the plane of the coil is horizontal, okay, so that when current flows in the arm A to B, the current is perpendicular to the direction of the magnetic field lines from north to south. We have studied that also. The lines of force travel from the north pole towards the south pole, okay. So in the arm, what is the first question? A, for this position, state the direction of the force on the arm AB. Okay, now you tell me first of all which rule is used to find the direction of this force. Yes, it is Fleming's left hand rule, which is also called as motor rule. Okay students, you have to remember that. So normally in the school exam level, what question you have been trained, directly the question is asked, what is a motor? You will write it converts the electrical energy into mechanical energy. Okay, then what is this principle you have studied? When a current carrying coil is placed in a magnetic field, it experiences a motor force, or it experiences a rotational force called as the torque. Like that you have studied. Similarly, which rule is giving the direction of the motor force you have studied? Fleming's left hand rule. Is it not? That is a usual question. That also you should be thorough. Understand? But how you are going to apply this? That is what Cbse is going to try to check whether you have understood the concept or not. Okay. Now, from Fleming's left hand rule, which three fingers we are supposed to use? Yes, you have to stretch the thumb. Okay. Then the forefinger and the middle finger, such that all the three fingers are mutually perpendicular to each other. Understand? Okay. Now you tell me, the middle finger gives the direction of which quantity? The current flowing through the coil. Then the forefinger represents the direction of what? The magnetic field lines or the magnetic field. And the thumb gives the direction of the motor force acting on the coil or conductor. Just I am going to use the Fleming's left hand rule. So once again I am reading the question. For this position, for this given position, that is coil horizontal like this, state the direction of the force on the arm AB. Okay, you can take this is A, B, C, D. Understand? So in which direction is the force going to act? For that I am going to first stretch the forefinger. Carefully you watch my forefinger. This finger gives what direction, you tell me? Magnetic field, is it not? See here, I am keeping my forefinger first of all. Is it facing north to south? Are you understanding? Good. It is north to south. Okay. Now in which direction the current is flowing? From A to B. Is it into the board or not? Current is from A to B means it is into the board. So I have to keep the middle finger like this. You watch my finger. You see here I am keeping it perpendicular to the board. Understand? Are you all watching now? Are you all able to see? I am pressing the board with my middle finger. That is the direction of the current inward into the board. Now you watch both the fingers. Okay, these two fingers. See here. One finger, middle finger, is into the board. The other finger is from north to south. Automatically, can you see my thumb is pointing downwards? Yes, can you all see? Can you all see? Okay, so the middle finger is into the board. The forefinger is from left to right. Automatically, the thumb is pointing downwards. Understand? The thumb is pointing downwards. That is the answer to this question. Very simple. The explanation requires much time, but if you understood means how much time it is going to take is hardly half minute only, I will say. So you can directly write that from Fleming's left hand rule, the direction of the force is acting in the downward direction. So for this answer, okay. So answer is for A, from Fleming's left hand rule. Okay, from Fleming's left hand rule, the force acting on the arm AB is downwards. That's all is the answer. 1 mark. Understand? So for this part, how much mark is given is 1 mark. Directly you have to understand the question. See, every child of 10th standard definitely will know the statement of Fleming's left hand rule. Everyone knows the working of motor, construction of motor, commutator, everything you have studied. But application only is required for the Cbse. Understand? Don't expect direct questions hereafter. Put it, application is very important. Put it to use. I hope this part you have understood. Okay? Next part. Why does the current in the arm BC not contribute to the turning force on the coil? It's a very good question. I have already explained to you. in this branch B to see how does the current flow. The direction of the current is flowing in the same direction of the magnetic field. So here it experiences no force. So when will the force experienced by any branch of the coil be maximum is when the current flowing through that branch is perpendicular to the magnetic field, the force will be maximum. And when it is either parallel or anti-parallel means then the force acting on that arm will be zero, no force. Why? It is based on a higher level point which I am going to explain here. So you see here the turning force. Here the turning force depends on, okay, the turning force F is proportional to the sine of the angle theta. So theta is the angle between current and the field. For your level, I am saying that it is current and the field. At a higher level, I will say that it is the direction between current element and the magnetic field. Now it is not required for you. But I hope you must have understood that the direction of the current is perpendicular to AB but parallel to BC. Is it not? So what is the angle between current and the magnetic field in the branch AB? In the branch AB, how much you see here? FAB. So FAB is proportional to what? Sine 90. So sine 90 is what? That is the maximum value of sine theta. That is equal to 1. Is it not? Like that FCD is proportional to what? Sine of what angle? Sine 0. Therefore, the force acting on the branch FCD is equal to 0. Understand? So how to find this force at a higher level? Higher level means you can write this F is equal to B into I into the length of the side into sine theta. So this expression I am writing here for higher order thinking skill students. Understood? Because if you go to competitive exams or KVPY and all, such question will definitely come. In the regular class also, I have explained you the same. So B is the magnetic field in Tesla and I is the current in ampere. L is the length of the portion like AB or BC or CD, and theta is the angle between the current and the magnetic field. Okay, so for the first part, the current is flowing from A to B, that is inward into the board, and the force is acting in the downward direction from Fleming's left hand rule. For the second part of the answer, better you have to remember all these informations. Understand? Okay students, I hope you must have understood well. Fine. Hi students, now we are going to discuss the choice question for question number 6. A circuit contains a battery, a variable resistor and a solenoid. The figure below shows the magnetic field pattern produced by the current in the solenoid. So you can see here there is a battery, this is a variable resistance and this is a solenoid. These are the magnetic field lines around the solenoid. Okay, we have already studied in the regular class, is it not? When current is passed through a solenoid which is cylindrical in shape, having so many circular turns, the magnetic field inside the solenoid will be very strong and it will be uniform. Is it not? The field inside the solenoid is uniform. So it is represented by horizontal lines, is it not? Or in this direction means vertical lines which are perpendicular, okay, along the axis. You can see that these are the magnetic lines of force which are parallel and are very close to each other inside the solenoid, but they are spread a little far in the outside space of the solenoid. This we have studied in the regular class. Now in this, what is the question asked? Let us see now. A. State how the magnetic field pattern indicates the regions where the magnetic field is stronger. So in which region the magnetic field will be stronger? Stronger field is represented by what? The magnetic field lines which are very close to each other. We have studied the properties of magnetic lines of force. The magnetic field will be stronger where the lines are closer, and it will be weaker where in the regions where the magnetic lines are far away from each other. So clearly you can see that in the space inside within the solenoid along the axis the magnetic fields are very closer. So state how the magnetic field pattern indicates the regions where the magnetic field is stronger. That is the regions of a strong magnetic field. Okay, we find the magnetic lines are very close to each other. So first the answer to the part A let us write now. Okay, answer to this A. So in the region, okay, in the region where the magnetic field lines, where the magnetic field lines are closer, the magnetic field is stronger. Okay, magnetic field is stronger. This is the answer to the first part. What is the second part of this question? What happens to the magnetic field when the current in the circuit is reversed? Reversed means what? The battery terminals are interchanged. Plus becomes minus, minus becomes plus. Is it not? So what is going to happen? The poles of the solenoid will change. So now in this picture, existing picture, you see these are the lines of force. Is it not? So they are all towards, coming towards. Towards means it is a south pole. In this picture, this top end is south pole. These lines are leaving out. So this pole must be what? The north pole. So the outside the magnet, the lines will travel from north pole to south pole. From north pole to south pole. But inside the magnet, we have studied, is it not? The magnetic lines travel from south pole to north pole. So how does this solenoid behave when it is suspended freely? When a current carrying solenoid is suspended freely, it will align in the north-south direction of the S magnetic field. Is it not? Why? It behaves like a bar magnet. In the same way, here if the direction of the current is reversed means then the top end will become north pole and the bottom end will become the south pole. That is the answer. So the answer to the second part B. So when the current, okay, when the direction of current is reversed, when the direction of current is reversed, the polarities, okay, north-south polarities of the magnetic field, the polarities of the magnetic field get reversed. So they also get reversed. This is the explanatory answer. I hope you must have understood this well. Fine.